So, welcome to the Cryptography Basics workshop. This is going to be an overview of cybersecurity and ciphers. And if you guys don't already know me, my name is Ria Jetbani. I am a junior at Oxford Academy. And a fun fact about me is I actually have a 568-day Duolingo streak. It's one of my proudest accomplishments. So let's talk about cryptography and cipher basics. So today I'm going to be going over like there's at least hundreds of different cipher combinations that you can use to encrypt things, but we're just going to be talking about 3 of them. And let's get started. So what exactly is a cipher? So the cipher originated in Egypt in the medieval times, and after World War I, when the Zimmerman telegram used cryptography, it really blew up and became super popular, and was used to send like classified top secret information. And basically what a cipher does is it provides like an additional layer of protection. So let's say I was sending a file to my friend Angie, and some hacker in the middle of our file transport decides to come in and steal my file. If that file is encrypted or it has this cipher acting on it, it's going to be harder for that hacker to get into my file and actually figure out what I was sending and use my information. So these are the parts of a cipher. So over here, I'm not sure, can you guys see my mouse? I'm pretty sure you guys can, but let me know if you guys can.
We can. You can see it.
Okay, perfect, thank you. So this is plain text. So plain text means your original, no filter, nothing is going on weird with it. It's just your original text that you're planning on sending. I forgot to mention that for this workshop specifically, we're only going to be talking about encryption in terms of text encryption. You can encrypt files, images, just a whole bunch of things. But for this one, just to make it clean and easy for everybody, we're just going to be talking about it as if it's just text. So over here, we have the plain text, which is just, like I said, the original text. Nothing has been acting weird on it. And then over here, we have the ciphertext, which is this weird, hard to read. Like if I had just seen the ciphertext, I wouldn't know what that said. So it's that already encoded piece of information. And then over here, we have the key. So the value of the key changes based on the cipher that you're using, and I'm going to go more into depth about that in later slides, but it basically is like the little tool that you're going to use to be able to go from plain text to ciphertext, and if you know the key, you can go from ciphertext back to plain text. So before we get really into it, I just want to ask everybody if they know what encryption and decryption means. So can somebody like give me like not even like a formal definition, just what they think either encryption or decryption means?
I think encryption means like making it more secure, like into like a coded message, I guess. And then decryption means, well, solving the coded message, I guess.
Okay. Eric, I saw your message in the chat. Exactly right.
Did you call me?
Yes, I saw your message in the chat. Do you want to share something?
Oh, encryption is basically where you scramblize or like make the message so that another person can't understand it. And decryption is where you decode it. Decryption basically means decode the message.
Okay, all of those answers are completely right on the nose. I like to think of encryption as, the process of going from plain text to the ciphertext, and then decryption, the process from going from the ciphertext back to the plain text. So that little transition between the two strings is going to be what we call encryption today and what we call decryption. Okay, so let's get started on specific ciphers and we'll do some practice problems. And for Caesar and ROT13, I'll specifically be teaching you guys how to code out the program that will cipher through it, so you don't have to do it manually. But let's first talk about Caesar ciphers. So the formal technical definition of Caesar ciphers is each letter of the plain text is replaced by another letter in the alphabet, which is determined by a key. Basically, what this means in simple language is that you're going to shift the alphabet over by a set number for each of these letters. So, for example, if my key is 1, A would be equal to B in my new scenario. B would be equal to C, C would be equal to D, D would be equal to E. If my key was 2, A would be equal to C, B would be equal to D, so on and so forth. So there's always one key used per message in a Caesar cipher, meaning that there are only 25 ways you can encrypt a phrase in Caesar cipher methods. So that means that this Caesar cipher is really easy to crack, and we're going to be able to do it really, really quickly in a Python program today. And then ROT13 ciphers are Caesar ciphers, but they have a fixed key of 13 letters. So it's basically a Caesar cipher, but the key is always going to be 13. And the reason why it is 13 is there's 26 letters in the alphabet. So when you divide by 2, you get 13. And basically what this allows for us to do, you're going to see it on the next slide, but it basically allows you to set both of the variables equal to each other rather than saying like A is equal to B and B is equal to C. Instead, A would be equal to B and B would be equal to A, for example. So in this case, A equals N, and N in fact does equal A in an RT13 cipher.
Wait, what happens for like Z with the ciphers? Because there's something after Z.
So that's when you go back. That's a great question. So if let's say your key is 1 and you're doing a Caesar cipher and you have a Z, you'd go back to A. That's why there's only 25 ways you can encrypt a message, because if you do 26, you're basically going to be going back. A plus 26 is just going to give you A again. It'll make a little bit more sense when we do a practice problem. So let us try this one. So as you can see here, this is an ROT13 cipher layout. And going off of this key, basically, can somebody tell me, if I'm asking you to encrypt the word hello in ROT13 cipher, how would you write the code? Like, what's the encrypted version? I'll give you guys like a minute.
Can I say? Okay, U R Y wait, B.
That's exactly right. So in an ROT13 cipher, we were able to equate B and O. So that's why you didn't have to create a whole nother row over here with 13 more letters. It was just equal to each other. So that's exactly right. And hello, basically when you take these columns together, it's going to be URYYB. So hello in ROT13 would be URYYB.
Are there more ways to arrange it?
In an ROT13 cipher, this is the only way that you're going to get.
Oh, okay.
But in a Caesar cipher, you have 5 different options on how you're going to encrypt it. So it's a little different.
Oh, okay.
Okay, so let's actually try to code this out. Okay, if everybody could open up a REPL and set it as Python, and I'm gonna call mine OA hacks. Let's do the ROT13 one first. So I'll give you guys a minute to get your REPL set up.
You said Python, right?
Yes, please. Python is probably going to be the easiest way for us to do this. And I will warn you guys, it might get a little confusing. We're going to be building off of all of the function loops, all of the knowledge that you've had throughout the day to do this Cypher project. That's why this workshop is last. It is a little bit like more brain powered, but I'm sure you guys can get it. And if it doesn't make sense right now, just like private message me later on in the day. We can set up a time and call and whatever. Okay, also, since we're going to be doing the drawing behind the scenes, basically, I'd like if everybody fills out the attendance form right now, just so that we can start picking people for the raffle. And you guys all get like an extra drawing ticket for coming here today. So priority number one, setting up your REPL and then also filling out the attendance form, please. Okay, so actually I'll give you guys like one more minute.
Are you giving us time to fill out the application?
Yes, the attendance form and also to set up your Python REPL.
Okay.
Okay, I'm gonna go ahead and get started. So the ROT13 cipher, basically how we're gonna start off is we're going to first tell the computer what our non-encrypted alphabet is. So we're gonna say alphabet is equal to A, B, C, D, E, F, G. This is just so that the computer knows what order we want our original alphabet to be in. A lot of other programs, like it's just good practice to tell your computer what you're starting off with. So that's just a given. You're going to tell your computer that the alphabet is A through Z. You want to use a dictionary to do this? I guess you could, but for like simplicity purposes, we're not going to go into that today. If you want, we could like set up a call later and like try to do the dictionary version as well. Okay, so for an ROT13 cipher, we have the shifted over alphabet. So I'm just going to call my shifted over alphabet shift 13, and it's just going to be NOPQRSTUVWXYZABCDEFGHIJKLM. So basically what we did was we moved the alphabet 13 spaces over. And the reason why we did that is we know that A is equal to N, B is equal to O, C is equal to P, D is equal to Q, and so on and so forth. So yeah, Tara, that's a great question. And in Python, we don't need, Python is very close to English. I'd say like out of all of the languages we've learned today, Python is closest to English. So you don't have like unnecessary syntax. And honestly, Python is like one of the coolest languages just because it's so easy to translate. So everyone good with this so far? We basically just told the computer what our two alphabets are. Okay, we'll take that as a yes. And next, we're going to define a function called encrypt, which passes in a variable called plain text. So like I said before, we have plain text and we have ciphertext, and the process of going from plain text to ciphertext is encryption. So we're going to define this function called encrypt. So for defining a function, as Gabriel mentioned in the Python Basics workshop, you need a colon and then you need to tab over. So in this case, we're going to create a empty string called ciphertext that has nothing in it. It's just to tell our computer that when I'm looking through all of the shift 13 and all of these alphabet things, when I make a decision, I want you to add my letter into this string and eventually make a word out of it. You're going to see that more when we actually run it. So ciphertext is equal to this blank thing just to get it started. Why is plain text italicized? That's a really great question. I think it's just REPL trying to tell you that you're passing in a variable. I'm honestly not too sure. I was a little surprised too, but it doesn't really make a difference to your program, so I don't think you should worry about it. Okay, so another thing that we need to define and tell our computer is the length of the plain text. Okay. So basically what I did here was I created a third variable called plain text underscore length, and I set it equal to the length of the plain text that we're going to be entering in. Later on in the program, we're going to say plain text is equal to something, and that's what the cipher is going to encrypt. But for right now, because we don't know what we're going to encrypt yet, and we're making a general program instead of just hard coding it, we're going to create this plain text length variable. Okay.
Are we trying to like make the computer recognize something, or I'm not really sure what we're doing.
It's going to be really clear. I'm just trying to walk you guys through each of the lines of code, so that it's not just like I suddenly threw it on you and it's all going to make sense, but just understanding why we're doing them. Yeah, we're basically just encoding letters. We're taking each letter in the alphabet and finding its position in this string, and then we're going to find the same position in this string instead because it's already shifted over 13 letters. That's exactly right. And this function is basically just going to detail how to do that. Yes, like a C code. Perfect. Okay, so next we're going to create a for loop. So for x in range of plain text length, use a colon. So basically all this is saying for each, so let's say plain text underscore length comes out to be 3. So we're going to run this part of our function 3 times so that each of the letters are accounted for. So for x in range of plain text underscore length, we're going to create a new variable called alphabet index, which is equal to the alphabet string with an index of plain text of x. This is super complicated. If you weren't at the Python workshop, I think Gabriel very briefly covered it. But this is basically just accessing. What this one does is it creates a variable called alphabet index, and it looks at alphabet, and it looks for this letter x, or this variable x, I should say, in this string, and wherever that letter is, it's going to count how many places it had to look through before it actually found it. So that's what this index is going to do. So for example, if we're looking for, or our computer is looking for the letter H, so it's going to count. It's not this first one, it's not this second one, it's not the third one, not the fourth, the fifth, the sixth, the seventh, and it is the 8th. So then alphabet underscore index is going to be, the value of it will be 8, for example. Yes, so Theodore, that's just a comment to let you guys know that I'm talking about the ROT13 cipher. If this has no impact on the code, it's just a comment. Okay, let's try to finish this one up. So now we're going to call the ciphertext, and we're going to add Sorry, let me write it all out first and then I can explain it better. Okay, so now we found out that H is at the index of 8 in the alphabet string. So now we're going to count 8 spaces over in shift 13. So basically all this is doing over here is it's looking at shift 13 and it's counting the same number of places over. So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8, and H is going to be equal to U, for example. And over here, what this is saying is that go to my variable ciphertext, this string that I've created over here, this variable, and I want you to add this letter that I'm going to find for you using this, and I want you to add it to the end of whatever is in the current string. So as you run through the for loop, things are going to get added into the ciphertext, and it's going to eventually go from like 1 character to 2 to 3 and into the word. So is everyone clear so far? I know that this is like kind of a lot in comparison to the work that we were doing in other workshops. Everyone good? Okay. Then just really quickly, we want to print a little thing for the console that says ciphertext so far. And we're going to print the ciphertext. Basically, all this does is as it goes through the for loop, it's going to give us like a letter by letter shift through the cipher so that we can just, like Brandon and Aiden said, we can debug our program if necessary and we can see where the errors actually were. Plus, it's super cool to see it actually happening in real life. So we're going to print that, and then it is common practice to return your final variable, which is ciphertext. And that's the end of the definition of our function encrypt. So now we have a really great function that we can apply to any plain text, and we'll get the proper ciphertext using an ROT13 cipher. So now to actually test it out, we're going to put the variable plain text and set that equal to a string. I'm going to use hi, my name is Bria. You guys are welcome to use whatever you'd like for your plain text. And now to call your function, I think Gabriel also covered this. To call your function, you're just going to say ciphertext is equal to encrypt the plain text. What this is doing is it's saying that this variable ciphertext is equal to whatever value you get from encrypting the plain text. So it's just calling this function and passing the plain text variable into it. Is that clear? Sorry, this is. Okay, I see nothing in the chat. I'm assuming that means everyone's good. Okay. Okay, so ciphertext is equal to encrypt plain text, and then we're going to print the ciphertext. Okay, so let's just run this so far. So we should see, hi, my name is Bria, going from H to, I think it was, so if we run this, H became U, I became V, M became Z, Y became L, and it just goes through all of that. And my plain text, which was hi, my name is Bria, got translated into ciphertext, which is UVZ LANZRVFEURN. So hypothetically, if I was to send this encrypted text over the internet to my friend Angie, and she knew that I encrypted this with the ROT13 cipher, she could count backwards 13 keys, or a key of 13 on each of these letters, and she would have my original text. But if we want to decrypt it also in this same function, okay, so you guys didn't get anything when you press run. Did you guys say print? got an error?
Yeah, I also get an error. I don't know why.
I got an error on line 18.
On line 18.
Mine says line 6.
I think you should just try to check your code line by line. It's probably just a mistype or a spelling error. I think, yes, that is really true, Taryn. If you're missing your colon on line 6, that's definitely going to throw an error. So line 6 and line 10, just make sure you have colons there. If anyone else is still having trouble, you're welcome to share your screen. We do have 30 minutes of this workshop left, and I'd be more than happy to troubleshoot your programs with you. Okay, now it worked, but it only printed out a U. So I'm assuming that's a problem because of your for loop. So I would check in here if anything is different in here. Most of the time it's just because something is spelled wrong and something is inconsistent.
Can I share my screen? What's a substring?
A substring? A substring would basically be like we're taking a small part of the whole string. We're not actually going to be using that in our function today. It does get into like strings, and it's a little deeper than we'd like to go today. So let's try to avoid that.
My error says substring not found.
Okay, Edward, do you want to share your screen and we can all take a look?
I don't know why, but mine's is having an error on line 7.
Your for loop looks correct. I know this program is probably super difficult, so we should just try to take each one at a time. Okay, so define, encrypt, plain text, cipher,
On the line 15, go to the beginning of return.
yeah.
And then, oh yeah, go to like the R, like right before the R. And then click Shift Tab. And then press Enter one time.
Wait, it says line 11. I must have saw it wrong.
Okay, Karen, that's great. Hmm.
And line 19.
I can share my code with you guys. That might be easier if you can put it side by side and take a look. Oh, sorry. That's weird.
I'm not sure what's happening to mine. It's making like these weird noises.
I think that's just people leaving the call and coming back in.
Oh. Is it supposed to do something?
Your program?
Yeah. Because what's happening on mine is I don't have any error. It's just not coming up.
If you want to share your screen, I'll try to help you debug your code together.
Sure. Can you see it?
Yes, we can see it. Okay, so you define.
So this is my code, and then when I press run, it just does that. I'm not sure what that was.
Okay. Santa, do you know if like if tabs versus spaces matter in Python, or it just has to be consistent?
Yeah, because Python doesn't, I mean, they do use colons, but it does matter.
Okay, so I think the spacing is inconsistent in the program. So I would say for like line 7 and 8, you should tab over so that they're all in line with that. And then ciphertext also needs to be covered.
Do I do it for 6 too?
No, you do it for 10, 11, 12, 13. Basically, it just has to get like this. Yeah.
Like that?
So 11, 12, and 13 also need to be tabbed over. Understand?
There.
So on line 11, you should add one more tab so that it, yeah, so one more tab over. Same thing for ciphertext, and they should all be in line with each other. Okay. Right, and then your return one should be in line with your for loop. So click backspace on the return ciphertext. I think that's line. Okay.
Okay.
And then your plain text, ciphertext, and print lines should all be right at the edge of the page. Like just backspace like 2 times.
Like that?
Yes, and then for 18 and 19.
Just like that.
Yes, I think that should be.
Oh, okay. Thank you.
Of course. So as we saw here, tabs matter in Python. Thank you, Sonnet, for your help. And is anyone else having other issues? Edward,
It's still not working.
would you like to share your screen? Forget. If you go to line 3 and you spell alphabet ALPHABET, could you click run, please? Okay, so line 19, ciphertext is equal to encrypt plain text. It calls the encrypt function. And in line 11, alphabet index equals alphabet dot index plain text. Does anyone else see the error?
I don't see the error, but it might have something to it something previously that ends up causing something different to happen there.
So it's telling us that line 19, when it calls the encrypt function, there's an error on line 11 and that the substring is not found. So,
But there is the wait. Okay, I don't know what's going on.
debugging God Sanith Nair. Do you notice
Yes, hello.
You notice anything? I don't see it. Is your ciphertext, are those quotes different? They look like different colors, so I think one might be single. Or that might just be my screen.
Well, Okay, wait here. We're gonna debug this. Okay, so before you say alphabet underscore index, can you go to the beginning of line 11? Yeah, not the beginning, like right before the A. And then hit enter. And in the line above, can you write print? And then put the parentheses, like open, yeah, and then now put remove the quotations and just do plain text. And then the bracket. No, the square one, yeah, and then put X. All right, cool. Now just hit run. All right, E is the problem word. Wait, Ria, are you sure it's index and not index of? Or is that Java?
I think index of is Java, and it works for me and others. Could you go to line 7 and just delete your quotes and like type them in again? I don't know why they just look like different colors to me, but I like to. Could you do 2 double quotes? Perfect. And could you click run, please? I don't think this will do anything. It's just for satisfaction. Okay, so now your H showed up. Was that there before?
Yeah.
Never mind. Okay, I was being wishful.
On index E.
What we can do is I can go ahead and teach you guys about the next cipher, and then while everybody's working on the practice problem, Edward, you can share your screen again, and we can try to resolve it like one more time.
Oh, I just noticed for the ROT13, all of them have to be capitals, right?
All of them have to be capital.
Yeah, for ROT, three
Um,
of the have to be
They don't
capital.
have to be. When you get into more advanced cryptography, you learn about something called ASCII, which is like numbers. It's like hexadecimal numbers for all of the symbols you'll ever type in your lifetime. And it's super cool, but I didn't want to get into it because it's a little complicated today. So I just made the things completely capital letters. But in ROT13 ciphers, you have like lowercase letters, uppercase letters. Yeah, you have both.
Wait, Ria, before you continue, is Gavin in this call?
Gavin? I don't think so.
All right, never mind.
Okay, let us continue. So feel free to take a picture of this. I'll send it out. When we send out the recap, I'll send out this too. So not a problem. And just for time's sake, let's not do the Caesar cipher coding. I have coding for 3 of them, so let's just stick to the RT13. It's probably the easiest one. One other thing I really quickly wanted to show you guys on the ROT13 is if you wanted to, so the reason why I chose the ROT13 one was if you run the encrypt function on the plain text 2 times, you're basically encrypting it and then decrypting it, because 13 plus 13 is 26. And like we mentioned before, if you shift by 26, you're basically coming back to A. So just to show you guys that, I was going to show like decrypted. So I'm making a new variable called decrypted, and I'm going to re-encrypt the cipher text this time. Rather than encrypting the plain text like we did before, I'm encrypting the cipher text that was returned as part of this encryption. And then I'm going to print the decrypted variable. So this should show you it going from hi, my name is Ria to this UVZ thing, and then going from UVZ back to hi, my name is Ria, still using the same function.
What exactly would that do?
So as you can see here, so these couple of lines we already had that when we ran it the first time. But now when I ran it the second time, U went back to H, UV went back to HI, and you were able to use the same encryption function to actually decrypt your cipher as well.
So you decrypted everything.
Yes. So
Oh, okay.
like over here, actually, okay. So where this like line of dashes is, if I encrypt my text and I sent this UVZLAN code to Angie, and Angie just has this UVZLAN code, and she runs the function on that. If you ignore this top part, and she just has this phrase, she could run her code, and then she would get original plain text, which is the original highlighting. That's just you. You didn't have to code out like a decryption function or something like that that you'd have to do with the normal, typical Caesar cipher or other type of cipher. So this is just little hint of extra stuff. But let's move on to rail fence ciphers. I'm gonna like not do any more coding for today. I'm kind of running out of time. But I still want to cover some more ciphers. So we're gonna talk about rail fence and transposition. These are actually like super cool because it's like, who even came up with these? So the first one that we're gonna talk about is rail fence or Zig Zag ciphers. And basically the technical definition is that you write it in a downwards diagonal. And then once you reach the bottom, you go upwards and you just keep going in that zigzag pattern until you write out your whole plain text. And once you've written out your whole plain text, you would read the code from left to right, just like row by row. So it's basically just like a word scrambler, but it's laid out in a nice, pretty graph. So let's do a practice question. So this is a secret message. Oh, and really quickly before I forget, the key in this case represents the number of rows. So like I said before, the key, sorry, I did not say this before, but the key would be the number of rows. And basically it's just telling you like how far deep do you want the zigzag to go before it changes direction again. So to encrypt it, you would write the plain text, like I said before, and you just zigzag all the way through. So for this is a secret message, can anyone tell me what the encrypted version would be, reading the text from left to right instead? Any guesses?
So it would be backwards, basically?
Oh wait, can I say?
Yeah.
Okay, so it would be TIIAERTSGHSS-CEMSAE.
That's exactly right. So the rule of the zigzag cipher is you write it in this weird wonky zigzag and then you just read it all the way across. So like Abraham said, perfect. It's TIIAER, blah, blah, blah. I'm gonna give you guys like 2 minutes to draw out. So I would suggest you draw out your grid on a piece of paper and like write it down instead of trying to visualize it. And if you guys could encrypt OA hacks is fun using a key of 4, which means that you're going to have 4 rows, what would the encrypted version look like? I'm gonna give you guys like 2 minutes. Yes, Taryn, it would mean 4 rows.
So in 4 rows, we would do that like zigzag cross method.
Yes, so you'd go down, and then when you hit the bottom, you'd go back up, and then when you hit the top, you'd go back down, just like this. Actually, I can't.
Okay.
And then just like in the chat, you can write down what you think the encrypted version is as soon as you get it. I'll give you guys like 1 more minute. Okay, so Terrence says OSAKINHCSUAF, and Abraham says that too. Let's check it out. And yes, that is right. So basically, I just made like a really quick crossword looking thing. No, Sudoku looking thing. And because I had a key of 4, I had four rows, and I wrote OAHACKSISFUN, and then I just read across. So OSAKINHCSUAF. Is that clear for everyone? I know, literally, who would think of this? Like, literally, who would think of this? But that's what makes it hard to decrypt. Okay, cool. The next one, or actually the last one that we're going to cover in depth, is called the transposition cipher. This is another one that's just like, why would you ever do this to yourself? But it's super fun to try and draw out the grid. So the technical definition is you're basically going to alphabetize your key and scramble things based on your alphabetization. It's super weird until you see it. But basically your steps are you're going to make, so you're given a key, but this time instead of the key being a number, it's going to be a word. So you're going to write that word out, and you're going to, those are basically going to become the column headers for your table. Then you're going to write the plain text into all of those boxes. You're going to see it on the next slide, and you're just going to write it left to right. Then you rearrange the columns around so that the first line, or the key, is in alphabetical order. And then you read it. Instead of going left to right, you're going to read it from top to bottom. Super weird. Who would have thought of that? But it works, right? So let's try this transposition cipher together. And you're basically encrypting hello using a key of hi. So as you can see here, we wrote the key of hi at the top, and I wrote HELLO, and this little space over here where it has a dash, this is called a null space, basically because it didn't even out and it didn't fit perfectly like the last one. We just have to put something like this called null that just basically tells you that there's nothing over here. So once we wrote that out, if H and I, in some parallel universe, I came before H, we'd switch the order of the columns. But in this case, because H does come before I, we didn't change anything in the order. So H and I stayed the same and the columns stayed the same. And now, does anyone remember which way we read the cipher this time? Not left to right, but
Wait, isn't it like
or up to down?
Wait, can I say?
gosh,
So it'd be HHLOIEL or is it HIHELLO? Wait.
so like Terrence said in the chat, you're going to read it top to bottom, and you're actually going to ignore the key. Once you've rearranged it based on the alphabet, you're going to ignore the key. It's irrelevant to you. So you're going to read it top to bottom, and it's going to be HLOEL null, like this. I know this one's a little weird, like why would this make sense to anybody? But it is a very commonly used transposition cipher.
To be honest, if someone found our last one, it doesn't sound too far-fetched. Someone found this one.
That is true. So Taryn asked, so the top word, if it was longer, could it be a word scramble? A longer word could be a word scramble to find a keyword. Yeah, it was, yeah, you could unscramble the top row. If you had the grid, you could unscramble the top row and you would actually be able to read it. Most of the time when you get the ciphertext, you're only left with this, just this one string of text rather than this whole grid, right? So probably not going to be able to see it. Yes. Okay, so let's try one more practice problem on the transposition cipher on our own. So using a key of cyber, let's encrypt the phrase "OA hacks is fun" on just 2 minutes. And I'd highly suggest writing it out. It's really, really hard to visualize otherwise. Okay, so if anyone got their ciphertext, you guys can put it in the chat. And in terms of how to unscramble it, this one is really, really difficult to unscramble. It's really complicated. A lot of times you just end up not being able to unscramble it by manually. Okay, bye Theodore, bye Trit. Thank you guys for coming. So for this workshop, we're just going to ignore any chances of decryption. We're just going to safeguard our own information and pretend like we're only encrypting it. So Taryn says HI null OKUAS null CF null ASN. So let's take a look at that. And that is right. So basically, I wrote out the key of cyber in bold at the top. And because it has, I can count 5 letters, there are 5 columns. So I wrote out OA hacks is fun in those 5 columns, and because it didn't even out, I had to add 3 null spaces. Then cyber is not in alphabetical order, so I had to alphabetize the rows. Notice how the column is exactly the same, BHI stays BHI, but just the order in which you're reading it, it changes, right? So BCERY. Once you do that, now you're going to read it from top to bottom. So HI null, OKU, AS null, CF null, ASN. And that's how you get that ciphertext. Yeah, it's really important you don't forget about the underscores because they represent spaces in your cipher. I think when you decrypt it, if your word has the same letter in it, how would you scramble? That's a really good question. I would assume that you would have 2 different ways of ciphering it then, but I'm not sure. I've never had that. That's a really good question. Oh my God. I will try to figure that. I will make a note and try to figure that out. And then I will email you that. Okay. Multiple letters in key. Okay, cool. So we're nearing the end of our workshop, so I won't be going over the coding of the transposition ciphers. If you guys are really, really interested in this kind of thing, as I said before, feel free to email me. We can set up a time and we can walk through the code together. We can even do the Caesar cipher code, whatever you guys would like. I'm available, don't worry. So just let me know, and I'll send out, if you guys want, I can send out like a written up version of all of this so that you can still walk through it at home in the recap email. But yeah, just to wrap up, so some other ciphers that we didn't cover. So the more traditional ones that are actually used very, very often are the Vigenère cipher and the Diffie-Hellman cipher. So those 2 are used very, very often in cryptography. Really, really cool. And then they have like hundreds of other ones. There's super random ones like Bacon cipher, Hill cipher, Shackle code. Honestly, if you're interested in it, you could just search up a list of classical ciphers, and I think Wikipedia has hundreds of different ciphers, and you can just go on this rabbit hole from there. So really, really cool.
I have a question.
Yes.
Who decided to name a cipher Bacon?
I don't know. Like, I'm assuming the person's last name was Bacon, but again, why would you do that to yourself? But no, we'll have to find out. If you find out the answer, you can let me know. And then really quickly, I just wanted to, I know that this was supposed to be the cybersecurity related workshop. So really quickly, I wanted to tie in how cryptography is used in the cybersecurity industry. So obviously cybersecurity is safeguarding your identity, your data, your computer towards online attacks. And cryptography is actually used to safeguard your data through encryption. So some really typical uses of encryption method used in cybersecurity, these are kind of, you have to kind of go in depth. There's something called RSA encryption, which is also known as public key cryptography. Basically what we did today, especially with the ROT13 cipher, that's called symmetric algorithm. So it has the same key for encrypting it and the same key for decrypting it. In an asymmetric algorithm, however, the key to encrypt would be different than the key to decrypt. So that's just something that bigger companies that have a lot to lose, they use that to make sure the people that they want to access their data is like the actual person that gets their data. So they would send like a private key to the other person and say, hey, like you can actually unlock this, like I'll allow it. And then the other way we use encryption in cybersecurity is through hashing. So hashing is basically when you encrypt things. So this would be when you think of encryption in terms of a file. So if you would encrypt a file and the file's hash is basically their unique identity. It's like your ID card if you're a file. And if the file is changed from the inside, then the hash changes. So that's how you know, like, you can compare hashes in your logs and things like that, and you can know whether your file has been manipulated or changed or anything like that. So that's used in Trojan horse malware, which basically just means like malware that's hiding as like a virus that's hiding as something good on your computer. So that's how we can use these cryptography methods in cybersecurity. So these would be the more real world applications of it. If you guys want to talk more in depth about this, always available. My email is everywhere, Discord, anything you'd like, always available to talk cybersecurity.
Do you want me to send you a message in Bacon Cipher?
Sure, I'd love to hear more about Bacon Cipher.
Here, there's a message on base. That's literally a four-word sentence. It's literally.
Yes. So basically, let us take our group photo. This is our last workshop of the day, and we're going to go straight into our closing ceremony. I think, did Edward leave? Oh, Edward, you're still on here. If you want your program to work and you want us to try to take another look at it, I really don't see the issue, but I'd like to at least try to take another look. So feel free to like message me on the Discord server and we can try to like look at that. And let us take this picture. So everyone could smile, please. And 3, 2, 1. Okay, perfect. And I think we are going to go into the closing ceremony in just a little bit. I think that's supposed to start in 5 minutes. So we'll take a 5-minute break and I'll see you guys all back here for the closing ceremony. Thank you guys for attending.